Good morning, student. Today we are going to learn flash memory. After the completion of today's session, you are able to define flash memory and explain the operation of flash memory. Flash memory is a non-volatile memory chip used for storage, and this is a type of EEPROM. In flash memory, each memory cell looks like standard MOSFET except that the transistor has two gates instead of one. Means in ordinary MOSFET there is only one gate present, but here two gates are present. See here, one is control gate, another one is the floating gate. The two diagrams are of flash memory. Okay, so here two gates are present. The cells can be seen as an electrical switch in which current flows between two terminals. We know that is from source to drain, and is controlled by a floating gate and a control gate. Means we know that the current flowing through the MOSFET is controlled by the gate voltage. So here it is controlled by two gates, as there is two gates are present, that is floating gate and control gate. The control gate is similar to the gate in the MOS transistor, but below this there is a floating gate insulated all around by an oxide layer. See here, this cream color portions are insulated layer that is present all around the floating gate. Okay, because the floating gate is electrically isolated by its insulating layer, so electrons placed on it are trapped. Means when electrons are present within this floating gate, they are trapped, as there is oxide layers are present all around it. Okay, means electrons placed on it are trapped there. This makes flash memory non-volatile. Flash memory works by adding or removing electrons to and from a floating gate. Okay, a bit 0 or 1 state depends upon whether or not the floating gate is charged or uncharged. Okay, when electrons are present on the floating gate, current cannot flow through the transistor and the bit state is 0. Okay, when electrons are present within this floating gate, at that time current cannot flow through the transistor, so that state is known as 0. When electrons are removed, means there is no electron present in the floating gate, current is allowed to flow and that bit state is 1. The memory cell can have two threshold voltages as per presence of electrons in the floating gate. Two processes are used to add electrons in the floating gate. First one is the Fowler-Northim tunneling method and second one is channel hot electron injection method. So first we discuss about the Fowler-Northim tunneling method. In this method, it requires a strong electric field between negatively charged source and the positively charged control gate to draw electrons into the floating gate. So see here strong positive voltage is applied, and in source and drain will be having strong negative potential. Okay, so the positively charged control gate draw electrons into the floating gate, means attract the electrons into the floating gate. Okay, the electrons move from the source through the thin oxide layer that is known as tunneling oxide. Here you can see tunnel oxide. Okay, so through thin tunnel oxide layer to the floating gate, where they are trapped between the oxide insulation layers. Next is the hot electron injection method. It uses a high current in the channel to give electrons sufficient energy to break through the oxide layer, means through this tunnel oxide layer. Here we are giving high current, and at control gate positive voltage is given. A positive charge on the control gate attracts the electrons from the channel into the floating gate, where they become trapped. Next we discuss about the process how we remove the electrons from the floating gate. For that we use Fowler-Nordim tunneling method. Here a strong negative charge on the control gate forces, here you can see 0 volt, or here we give negative charge, we can say. A strong negative charge on the control gate forces the electrons through the oxide layer, tunnel oxide layer, into the channel, where the electrons are drawn to the strong positive charge at the source or drain end. Okay. Next, there are two types of flash memories are present, that is NOR flash and NAND flash. NOR flash. In a NOR flash memory, at least one memory cell must conduct in order to pull down the bit line. This one is the bit line, because they are connected in parallel to ground. Okay, let's see the main diagram of flash memory. Here you can see the control gate is known as also word line, and the drain terminal is called as bit line. Okay, referring to this terminals, here we can say the drain of the transistors are connected to this bit line, and the source of the transistors are connected to ground. So NOR flash uses more space than NAND to save the same amount of information, since two flash cells share the same ground potential in this configuration. Here we can see that two transistors share the same ground potential. Okay, because of this the NOR flash memory is expensive than the NAND memory. Okay, and also the NOR memory needs less time to read a bit because of its direct access to individual cells. Okay, next, NAND flash. In a NAND memory chip, all floating gate MOSFETs are organized in series connection. Here the bit line is pulled low only if all the word lines are pulled high, as they are connected in series. This is the bit line and the gate terminals are word line. So the NAND cell is cheaper than the NOR flash cell. Okay, so this is all about flash memory. Thank you.